Good morning, dear students. I am Dr. Srinivas Batini, Professor of Chemistry in St. Peter's Engineering College. Today we are going to discuss about the types of corrosion and factors effects. Two topics, try to finish in this video. So what are the types of corrosion? Types of corrosion and factors effects. What are the factors? So in the last video what we have discussed, the last two videos, theories of corrosion we have discussed. Dry theory and wet theory of corrosion. So in wet theory there are again divided into two types: evolution of hydrogen gas and absorption of oxygen gas. Finally form the Fe2O3, that rusting product in absorption of oxygen. Okay, and in dry theory there is a chemical effect, the chemical reaction takes place, especially absence of moisture. So this one is the wet mean presence of moisture. So that is react with the oxidation. They are further divided into three types: oxidation reaction, and react with the other gases, and liquid metal corrosion. So that is about the theories of corrosion. There are the two theories, wet theory and dry theory. That was completely finished. So you have to remember two theories are very important. And what are the types are there in the corrosion? What are the types? Mainly, basically, 8 types of corrosions are there. So 8 types. Among that few are we will discuss. So first of all, so what are that? Uniform corrosion, pitting corrosion, uniform corrosion, uniform corrosion, pitting corrosion, intergranular or intergranular mean crystallization concern. Intergranular corrosion, intergranular corrosion, concentration cell corrosion, concentration cell, stress corrosion, galvanic corrosion, erosion, stress corrosion, galvanic corrosion, and erosion also there. Erosion and crevice corrosion. So mainly these many, basically we have discussed all these things. So many types are there according to our syllabus. So we have galvanic corrosion and concentration cell corrosion, pitting corrosion. So these are three mainly we have to discuss. Okay, so once again, what are the types? Uniform corrosion, pitting corrosion, intergranular corrosion, concentration cell corrosion, stress corrosion, galvanic corrosion, erosion and crevice corrosions are there. Okay, so first among that, so this we will discuss the important galvanic corrosion, concentration corrosion. Example is the water line corrosion. This one, water line corrosion, best example. Aeration, we can say aeration. And pitting corrosion, we will discuss pitting corrosion, waterline corrosion, galvanic corrosion and crevice corrosion also we will discuss that one. So first the main important thing is first we will discuss the galvanic corrosion. It's important. Just in the last video we have discussed the what? theories of corrosion. In this, the second one is dry, wet theory, that is act as a galvanic cell. So, being two dissimilar metals. So, one diagram I will draw it. So, two dissimilar metals. We have write the one dipped in this is the copper metal, this is the zinc metal. Okay, dipped in there, partly and here what happened, two decent, one is the oxidation, another one is the reduction. So this one is the copper acts a reduction, you can say reduction, copper act as a reduction, is an oxidation. So oxidation, we know that lost the 2 electrons, mean zinc lost 2 electrons to form the zinc plus 2 and 2 electrons. Copper takes 2 electrons to form the copper metal. So this is about the reduction. So mean which is anode? This is the anode and this is the cathode. This is the galvanic corrosion. What? Galvanic corrosion. In galvanic corrosion, what is that? Two dissimilar metals are there. So combined, partly dipped in the water. So here one is the act as anode, another one is the act as a cathode. So anode lost the 2 electrons, cathode takes the 2 electrons. So lost the 2 electrons to form the oxidation and the reduction. So this is about mean here that this is called the electrolyte. We can say electrolyte. Electrolyte. So here galvanic corrosion. So what we have taken, two dissimilar metals are in direct contact, in direct contact in conducting liquid. Experience shows that one of the two may corrode. So in this one metal among these two, one metal get corrode. One metal get corrode. This is called the galvanic corrosion. So what is the definition we can write? When two dissimilar metals are in direct contact in conducting liquid, experience shows that one of the metal get corrode. One of the metal among the two will get corrode. This is called the galvanic corrosion. The other metal will not corrode. One will get corrode, another metal. So it may even be protected in this way. So this corrosion is different in its kind and intensity from the one that occur if they are placed is separately in the same liquid. For example, same liquid you have to place it. One is here, another one is separately. We will get the galvanic corrosion. So same time, the corrosion occurs when the metals are dipped in the same liquid in separate time or same time. Okay. So this is about the galvanic corrosion. So galvanic corrosion means, so take the diagram, write the diagram, and here the anode. So we have to explain that zinc is lost the 2 electrons to form the zinc plus 2 ion. It takes the oxidation, and at cathode, that is cathode means it's a mechanism. So cathode takes the 2 electron to form the reduction. So this is the mechanism of the galvanic corrosion. So simple definition is what? Two dissimilar metals are direct contact in presence of liquid or dipped in the liquid. So to form among the two metals, one will get corrode. That is enough for galvanic corrosion. Okay, and next is the concentration cell corrosion. So concentration cell corrosion, this type of corrosion occurs due to the electrochemical corrosion. Electrochemical attack the metal. Electrochemical attack on the surface of the metal, surface under, in presence of electrolyte. So mainly this type of corrosion due to the difference in the concentration of metal ions or difference in the exposure to air or oxygen. That is we call the aeration. So best example, aeration corrosion. We can say aeration corrosion. Aeration corrosion, concentration cell corrosion. In this aeration corrosion, the best example is the waterline corrosion. Best example is the waterline corrosion. Best example. So best example mean when in a steel tank, containing the water, the steel tank containing the water, So here what happened? Steel is what? Iron. We know the steel is iron, this one. So iron always lost the 2 electrons. Okay. And inside what is there? Water is there. So water takes the water as well always presents H plus and OH minus. H plus and OH minus. That H plus react with the oxygen. So to form the 2H2O. So meaning 4H plus react with oxygen. Here 4H plus means here 4 electrons we can take plus oxygen to form the water molecule. So here what happened? So here the differential aeration corrosion, the best example is the waterline corrosion. Here what happened? The best example is the waterline corrosion. When water is stored in a steel tank, the corrosion takes place. A line just beneath the level of meniscus. Here the meniscus level is there, just beneath. This is the line. So beneath the water line, when the water is stored in a steel tank, corrosion takes place. A line just beneath the level of water meniscus. Here, this is called beneath the level. This is a water meniscus, and here the corrosion takes place. In this case, the area above the water line having the more access, mean the area above the water line. So here oxygen is available more, plenty of oxygen. Availability of oxygen is more. Whereas beneath the area, less amount of oxygen. The area of the water line having more access to oxygen act as a cathode. This one is the cathode. And this one is the anode. Beneath the area. Whereas the area below the water line having the relatively less oxygen act as a anode. So in the waterline corrosion, so what happened? Aeration, that is the reason we can say aeration. Mean plenty of oxygen available on the top of the water, and below the meniscus, small amount of here the less oxygen. Availability of oxygen is very less in the below the meniscus area. It acts as anode, it acts as a cathode. So we know the oxidation occur here and reduction occur here. Oxidation and reduction. This is the free electrons moving the iron electron moving and corrosion takes place here. Corrosion takes place here. This is about the what? Corrosion. Corrosion, water line corrosion. Best example is the water corrosion. So galvanic corrosion and aeration corrosion, that is the best example is the water line corrosion. And third one is the pitting corrosion. We can say pitting corrosion. Pitting corrosion. Pitting corrosion. So here same block, we have to take one block, iron block, iron block. Okay. So pitting means a small portion of block. So one pit takes place like this. One pit, small pit, small pit. So that block is exposed to what? Mean here what happened? If here rusting takes place. What rusting? Fe plus 2 OH minus to form the FeOH. We know the rusting from this oxidation law. Finally Fe2O3 and 3H2. This will happen. So here what happened? Here 2 moles of hydrogen mean that water, when the water moisture so react with the water, mean when the 2 electron block, iron block release the 2 electrons, iron block to release the 2 electrons. Here the electrons take the water and oxygen to form the OH. We know already in galvanic corrosion we have seen, so that iron lost the 2 electrons, okay, and this one takes the oxygen, half mole of oxygen takes the 2 electrons in presence of water to form the 2OH minus. So this one again here react with to form the corrosion. This is about pitting corrosion. Pitting corrosion. So just we can say pitting corrosion is a localized form of corrosion. We can say localized form of corrosion is characterized by the formation of irregular shaped cavities. Irregular shaped small pitting is there. Irregular on the surface of the metal. Irregular shape or pits on the surface of the game. So mean their diameter or depth depend upon the several parameters related to the metal, the medium and service conditions, whatever may be the several conditions. One is a cracks and pits are very mainly. So unlike uniform corrosion, the intensity and the rate of pitting corrosion can be assessed neither by determining mass nor by measuring released by the hydrogen. So just corrosion will occur on irregular shape. So this is called the pitting corrosion. Okay. So now crevice corrosion. That one more is a crevice. So crevice corrosion is also localized corrosion in recesses. So overlapping zone of reverting bolt. So we know some bolts. This is the bolt we are fitting some bolt. So inside this is a bolt. You can say the diagram. Otherwise it is a bolt. Bolt is like this. So one wheel, we have to threads are there. Simply the bolt are there here. So this is we have to what we say nuts and bolts. Nuts and bolts. So screwing like that we have said. So this the bolt is there. One nut we have to rotate it, will get tightly. So mean the overlapping zones of reverting or bolting are welding zones. We can say welding zones under the joints under various deposits. Either we can have welding zone or reverting zone. These zones also called as the crevices. That zones welding For example, here one metal. So we have to weld another metal. So this zone or this zone, this is the nut, this is the bolt, this is the metal, another metal. So this is the welding. So this zone or this zone is called the crevice zone, the small zone. These zones also called as crevice are very tiny and difficult to access for the aqueous liquid that is covering the rest of the readily accessible surface. This type of corrosion is also known as the deposit attack. We can say deposit attack. So these two. So this is called the crevice corrosion. Okay. So these are the main 3 or 4 important corrosions. What are the corrosions? What are the types of corrosion? We have seen galvanic corrosion. In the galvanic corrosion, anode and cathode is there. So best example is the iron black. So reduction takes place, oxidation. Oxidation means place to mean 2 metals we have to take galvanic corrosion. So 2 dissimilar metals, copper and zinc. Zinc is the oxidation, copper is the reduction. That is, and the second one is the waterline corrosion. Waterline just beneath the meniscus of water, the corrosion takes place. And pitting corrosion. So small portion of the pit act as a anode and larger portion of the cathode. So here the electrons are moving towards the water and act as a Fe2O3 formation takes place. So and crevice corrosion. Bolts, nuts or welding places are small amount, so get corroded. And finally, factors affecting corrosions. What are the factors? That is important. Few factors we will discuss. What are the factors? The rate and extent of corrosion. The rate and extent of the corrosion depends upon the various factors. Due to the nature of metal, and nature of corroding environment. Mean the metal, this is the metal, and corroding environment, either acidic environment or basic environment or neutral environment, that is depend upon that one. So what are the factors? So simply we have to remember the 10 factors are there. Just you have to remember. First is the purity of the metal. Metal should be pure. If impure metal will get corroded. First one is the what? Pure metal. Please note down. First one is the factors. What are the factors? First one is the pure metal. If it is not pure, will get. And electrode potential also important. Electrode potential. Mean electrode potential value -2, lithium metal minus, and above the hydrogen, below the hydrogen. That is the electrode potential. Having a different electrode potentials metals shows the different corrosion product. Okay, and position of metal in galvanic series. Third one is the position of metal in galvanic series. And fourth one is the relative areas of anodic and cathodic cells. Relative areas of anodic and cathodic cells. Relative areas. So relative areas. Anodic and cathodic cells. And hydrogen over voltage. If mean more hydrogen availability. Hydrogen over voltage. This is also one factor. And physical state of metal. physical state of metal and positivity of metal. Positivity metal. Positivity metal. So these are the 8 types. So and some metals are grazy and rough surface area, and smooth surface area. So different factors. So and nature and acidic environment, basic environment, neutral environment. So depend upon that. Moisture environment, moisture or dry environment. So these are the factors. So what are the factors? So it should be pure metal. If impure metal, get the rust. And electrode potential, if electrodes -3, -2, -1, 0, +1, +2, like that, that is the electrode potential. So different electrode potential metals shows the different corrosion product. And position of the metal in a galvanic cell. So it is an anodic metal or a cathodic metal. That is the position is important. And relative areas of anodic and cathodic cells. And hydrogen over voltage and excess of hydrogen and physical state of metal. So physical state is the metal is placed in outside of the environment or inside of the environment, or acidic environment, or basic environment, or larger size, or smaller size, or crushed one, or smooth one, or shining one. Different physical state. We don't know. The physical state also important. And nature of the surface of film. We can say nature of the surface of film. So what is the nature? Mean that is the surface area, smooth area or rough area. Okay, and positivity, acidic environment. So all these things are factors. Just write the names of the factors. Okay. So today we have discussed what types of corrosions. Mainly we discussed the galvanic cell, pitting corrosion, and waterline corrosion, crevice corrosion. Okay, and factors. So 8 types of factors are there. So these are the important factors. Okay, thank you.